On a warm August night in 1977, a radio telescope in Ohio recorded a burst of energy from deep space that lasted exactly as long as the physics of the instrument predicted it should, rose and fell in precisely the right pattern, and has never been detected again in the nearly 50 years since. On a flat stretch of land in Delaware, Ohio, there stood a radio telescope that could not move. Most telescopes pivot and swivel, following objects across the sky the way eyes follow a slow-moving bird. The Big Ear was different. It was fixed to the ground, a vast horizontal structure, something like an enormous table laid open to the heavens, its combined structures covering ground roughly equal in area to 3 American football fields. It could not tilt. It could not turn. It simply waited, face up, aimed at a single strip of sky, and let the rotation of the Earth do all the moving for it. As the planet turned, that strip of sky slid slowly overhead, and whatever the universe had placed there passed through the telescope's view, the way a landscape drifts past the window of a moving train, steadily, silently, without any particular urgency. This was, in its own way, a kind of patience that mechanical instruments are particularly well suited to. A human observer watching the sky through an eyepiece for hour after hour will eventually grow tired, lose focus, start to see things that are not there, or miss things that are. The Big Ear did not tire. It recorded what it received, and it recorded it in the same careful, methodical way, whether the sky offered something interesting or offered nothing at all, which was, on almost every night across almost every year of its operation, precisely what it offered. The telescope had been built in the 1960s as part of a long, deliberate search, one of the first serious, sustained attempts to listen to the sky for radio signals that might not be natural in origin. The people who designed it understood that this was the kind of project that could not be rushed. If there was anything out there worth finding, it would not announce itself on a schedule convenient for human institutions or grant cycles or careers. It would arrive on its own terms, or not at all. The Big Ear was built for exactly that kind of waiting. Its design was straightforward in principle, though impressive in scale. There was a large flat reflector on the ground, the part that actually caught incoming radio waves, and a pair of curved surfaces at either end that helped focus those waves toward the instruments that would measure and record them. The whole arrangement was oriented so that as the Earth turned, the telescope swept through the sky in a series of long, slow passes, each one covering a narrow band of the heavens, and then moving on, returning to the same strip only after the planet had carried it away and brought it back again. The sky, from the telescope's perspective, was like a long ribbon being slowly reeled across a fixed point of observation. What the telescope was listening for, specifically, was radio energy, the same general phenomenon as the signals that carry radio broadcasts, though originating not from any human transmitter but from sources out in space. The universe produces enormous amounts of radio energy naturally. Stars produce it. Clouds of gas produce it. The faint residual warmth left over from the very earliest moments of cosmic history produces a kind of radio whisper that fills the sky in every direction. Most of what the Big Ear recorded was some version of this background, the ordinary, continuous murmur of a universe going about its physical processes without any particular message to send. The data came out not as a sound but as numbers, printed in columns on long rolls of paper. Each character in the printout represented the strength of the incoming signal at a given moment, measured against the surrounding background noise. Most of the time, most of the characters were low numbers, or letters at the lower end of the scale the system used, indicating that nothing was arriving beyond the expected background hiss. A typical night's printout looked like a long, quiet document, columns of 1s and 2s and the occasional 3, stretching on across page after page, a paper record of silence rendered in ink. The people who worked on the project, Astronomers, graduate students, volunteers would go through these printouts looking for anomalies, for any sequence of values that rose meaningfully above the baseline. It was painstaking work, and for most of the telescope's operational years, it produced nothing that required much attention. The sky, as the Earth carried the big ear through its long and patient arcs, mostly kept its counsel. Years went by this way. The printouts accumulated. The background noise remained background noise. The telescope continued its slow, methodical sweep across the heavens, recording the ordinary in careful columns, storing it all away in the mute and unhurried language of numbers on paper. There was a quality to the work that was less like searching and more like listening in the way one listens, in a very quiet room, not straining, not hoping, simply remaining attentive, because that is the only disposition available to those who are waiting for something that may never come. And then, one night in the summer of 1977, something came. The summer that year had settled over central Ohio with the particular density of late August heat, the kind that lingers in the air after dark without much apology, warm and still and faintly electric in the way that humid nights sometimes are when the sky is clear enough to see all the way to the edge of the atmosphere. The corn was high in the fields around Delaware, Ohio, the town nearest to the telescope, and the insects were making their full summer noise in the grass and in the hedgerows, and none of that reached the instrument itself in any meaningful way, because the big ear was not listening to anything so close. It was listening outward, as it always had, as it always did, in the only direction available to it. The flat reflector lay tilted and fixed, drinking in radio waves from a narrow strip of sky, and the Earth beneath it turned at its own slow and ancient pace, carrying that strip of sky gradually westward through the instrument's field of view, one thin ribbon of the heavens at a time. This was the rhythm of the work. It had been the rhythm for years. Each patch of sky that drifted into the telescope's line of sight was held there for a little while, just over a minute typically, before the rotation of the planet carried it past, replaced by whatever lay just beyond it to the west, and then whatever lay beyond that, all of it moving with the unhurried geometry of a world that does not concern itself with what is being observed. There was no one standing at a console watching the data come in. That was not how the work was done. The telescope gathered its information and passed it along to a computer, and the computer converted what it received into a series of characters printed on long sheets of paper, a column of letters and numbers corresponding to the intensity of the radio signal arriving from each successive point in the sky. Most of what arrived was very quiet. Most of what arrived was the low, featureless hum of the background, the diffuse radio wash that fills the space between everything, and those quiet readings translated into single-digit numbers on the printout, sometimes a 1 or a 2, occasionally a 3, arranged in their columns in a long and unremarkable parade of ordinariness that stretched across page after page after page. The telescope did not find this unremarkable. The telescope found nothing remarkable or unremarkable. It simply received and converted and printed and moved on. Sometime during the night of August 15th, 1977, the instrument swept across a region of sky in the direction of the constellation Sagittarius, that dense and crowded region of the southern summer sky where the center of the galaxy lies behind veils of gas and dust, thickly starred and ancient. The telescope passed over it, the way it passed over everything, without ceremony or hesitation, the Earth's rotation carrying it steadily through. And something was there. Not something visible, not something the eye could have caught even with the sky perfectly dark and the air perfectly clear. What was there was a pulse of radio energy, narrow in its frequency, strong in its intensity, rising as the telescope's effective window swept across it, and fading again as that window swept past, the whole encounter lasting 72 seconds from beginning to end, the span of a little more than a minute, the same length of time. The telescope spent looking at any fixed point in the sky before the planet's turning moved it along. The computer received it. The computer did what the computer always did, which was to translate the strength of the incoming signal into a character on the printout. A quiet signal, a normal signal, a background level signal might earn a 1 or a 2. A somewhat stronger signal might earn a 6 or a 7. The characters ran in sequence through the alphabet when the numbers ran out, so that a 10 became the letter A, an 11 became B, and so on up the scale. The sequence of characters printed for that 72-second encounter with the thing in Sagittarius read 6EQUJ5. It sat in its column among all the other columns, all the other characters, all the other rows of numbers and occasional letters that represented everything else the Big Ear had received that night and every other night. It occupied no more physical space on the printout than any other sequence. The paper did not tremble, the machine did not pause. Whatever quality of signal the letter U represented, a strength roughly 30 times greater than the quiet background hum around it, a sudden and precise concentration of radio energy at almost exactly the frequency that theorists had long considered, a kind of natural, obvious channel for communication across the distances of space. None of that manifested in any outward way. The printer continued along its column. The numbers fell back toward the ordinary, and the paper kept feeding through. The night went on. The insects went on. The heat lay over the fields. Somewhere to the north, the lights of Columbus cast their orange glow into the base of the clouds, and the telescope went on recording the quiet sky as the Earth turned beneath it, carrying new strips of darkness into view and sweeping them past, one after another, steady and patient, as if nothing had happened. Because nothing had happened, in the sense that the machine experienced events, something had been received and noted. A character had been printed in a column. The printout had moved on. The work continued. The signal, whatever it was, did not repeat. It had arrived in the middle of the night while no one was watching, had been faithfully and precisely recorded in the only language the telescope and its attached computer knew how to speak, and had then been filed away in the accumulated paper record of an instrument that filed everything away, that considered nothing too small to note and nothing remarkable enough to require a response. The printout containing those 6 characters sat with all the other printouts, waiting in the way that records wait, inert and full of information, for the moment when a human being would come and read it. The information it carried, compressed into those 6 characters, described something that had arrived from a particular direction in the sky and at a particular frequency, and both of those qualities, taken together, were the reason the signal would eventually stop a man mid-motion with a red pen in his hand. The frequency first, because it is the stranger of the 2 facts, and the one that sits most quietly at the center of everything that followed. Hydrogen is the most abundant element in the universe, spread through the space between stars in vast, thin clouds that drift and slowly churn across the galaxy. When a hydrogen atom, in its ordinary resting state, shifts very slightly in its internal arrangement, one of those small, almost imperceptible adjustments that atoms make on their own, without any outside cause, it releases a faint pulse of radio energy. That energy travels at a precise and fixed frequency, the same everywhere in the universe, the same in a cloud near the center of the galaxy as in a cloud at its outermost edge, the same in the Milky Way as in any other galaxy where hydrogen exists, which is all of them. The frequency does not drift, it does not vary. It is one of the few things in the cosmos that is genuinely, unchangingly constant across distance and time. In the middle of the 20th century, astronomers and physicists thinking carefully about the problem of interstellar communication, about what channel, in the broad and crowded radio spectrum, might be the most logical place for one civilization to try to reach another, kept arriving at this frequency. Not because it was magical, but because it was obvious. Any civilization advanced enough to build a radio transmitter would know about hydrogen. Any civilization listening for signals would know to check here. The frequency of hydrogen was, in a sense, the one number that did not need to be agreed upon in advance, the one tuning point that required no prior introduction. Theorists called it a natural meeting place, a quiet harbor in an otherwise noisy sea of radio noise. If something out there were ever going to send a signal intended to be found, this was the frequency at which to send it. The signal recorded on the night of August 15th, 1977, arrived at almost exactly that frequency. Not approximately, not in the general neighborhood, at almost precisely the frequency that hydrogen emits, sitting so close to that natural constant that the deviation was smaller than the width of a human hair compared to the length of a room. Whatever had produced the signal, it had come in on the one frequency that anyone, anywhere, paying attention to the sky and thinking carefully about what to listen for, would have been listening for. The frequency alone would have been remarkable. The shape of the signal made it stranger still. Big Ear, fixed to the ground and scanning with the Earth's slow rotation, received signals in a characteristic way. As the Earth turned and a patch of sky drifted into the telescope's field of view, any signal from that patch would gradually increase in strength, reach a peak, and then gradually diminish again as the patch rotated out of view. The rise and fall followed a smooth, specific curve, like a slow breath, in, peak, out, and the whole passage, from first detection to last, took about 72 seconds. That was the geometry of it, the way the instrument and the Earth's motion together shaped what was recorded. A signal from something terrestrial, a broadcast tower, a satellite, a reflected beam of some kind, would not behave that way. It would arrive at a different angle, hold steady, or drop and return, shaped by the movement of whatever was producing it, rather than by the slow and predictable arc of the sky above Ohio. But the signal that arrived that night rose and fell in almost perfect agreement with the expected curve, for a source that was fixed in the sky, distant, unmoving relative to the stars, simply sitting in one place and radiating outward while the Earth's rotation carried the telescope's field of view across it and then away. The shape was clean. It matched the template exactly, or near enough to exactly, that the difference was negligible. The intensity was the third quality, and perhaps the most immediate. Background radio noise from the sky is constant and low, a kind of hiss that the telescope recorded continuously, a baseline against which everything else was measured. The characters printed on the datasheet represented signal strength on a scale the system used to make comparisons easy, where the background hiss registered as a low single digit or nothing at all, and stronger signals climbed higher. The 6 characters representing the signal that arrived that night climbed to a value roughly 30 times above that background. It was not a marginal detection, not a faint whisper at the edge of what the instrument could sense. It was, on the scale of things the telescope routinely recorded, enormously loud, a shout in a room where everything else was barely a murmur. And then it was gone. Whatever it was, it did not linger. The 72 seconds elapsed, the curve completed itself, the signal fell back to nothing, and the telescope's receiver returned to recording the ordinary background of the universe. The printout moved to the next column, and then the next, filling in with the usual low-level noise that constituted the vast majority of what the search ever found. The signal left no trail, no echo, no secondary detection. It arrived, completed its arc, and vanished into the data the way a stone vanishes into deep water. Present for a moment, then gone, with no disturbance remaining on the surface to show where it had been except the record it had made on the way down. What it was made of, in a physical sense, was radio waves, electromagnetic energy traveling at the speed of light, which meant that wherever the source had been, the waves themselves had been traveling for some portion of the enormous distances between stars, before arriving at the flat reflecting surface of a telescope in Ohio on a warm August night. Radio waves are invisible and weightless, carrying no mass and leaving no mark on the space they travel through. They pass through most matter without resistance, and they cross the distances between stars as easily as they cross a field. If the signal had originated anywhere beyond the immediate neighborhood of the solar system, it had been traveling for years at minimum, and possibly for far longer before arriving. It had crossed that distance in absolute silence, because space carries no sound, and arrived at the one instrument that happened to be pointed in roughly the right direction, at roughly the right moment, and tuned to receive the one frequency at which it had been broadcast. The printout recorded all of this faithfully, in the only way it knew how, as 6 characters in a column, surrounded on all sides by the ordinary noise of a universe that had not, before that night and would not again after it, produced anything quite like them in that part of the sky. Those 6 characters sat on the paper for days. The printout was not a single page, but a long, continuous roll, the kind of output that accumulated steadily through every observing session and was stored afterward in stacks for later review. It was part of the rhythm of the project that data came in faster than any single person could examine it in real time. And so the review happened afterward, in the ordinary hours of the working week, when researchers would sit with the accumulated rolls and move through them column by column, looking for anything that stood out from the expected background. Most sessions produced nothing that warranted a second look. The columns of characters were nearly always uniform, a steady recitation of low values that confirmed the universe was in that direction and at that frequency, and on that night, producing nothing remarkable. A person could develop a feel for what normal looked like after enough hours of this work, and what normal looked like was a great deal of sameness stretching from one end of a printout to the other. Jerry Ehman came to the data sometime in the days that followed that August night, and he sat with the printout the way one sits with any document that requires careful attention, methodically, without expectation, moving through it in the way that long practice had made habitual. He was a volunteer researcher associated with the project, a man who had spent enough time with this kind of data to know what he was looking at when the columns behaved as they almost always did. The work was not glamorous in any conventional sense. It was the work of paying close attention to things that almost never changed, which is a particular kind of patience that not everyone finds natural. At some point, his attention landed on the sequence. 6 characters, arrayed in a column, representing the signal's intensity at each moment as it had risen and then faded across those 72 seconds. The characters moved upward through the alphabet as intensity increased, and these 6 characters climbed in a way that no column in the surrounding data climbed, reached a peak, and then descended again in a mirror of their ascent. The shape of it was immediately legible to anyone who understood what the output meant. It was the shape of something real arriving from a fixed point in the sky, growing stronger as the Earth's rotation brought the telescope's field of view into alignment with its source, reaching maximum strength at the moment of closest alignment, and then fading as the rotation carried that alignment past. It was precisely the shape that a genuine signal from a distant, stationary source would be expected to produce, given the way the telescope operated, and it was a shape that had not appeared in the data before with anything approaching this kind of intensity. Ehman took a red pen and drew a circle around the 6 characters. It was a small gesture, the kind of thing a person does when they want to mark something for further attention, when the mind registers significance before it has fully assembled the reasons. The circle was not a conclusion. It was not an announcement. It was simply the physical expression of stopping, of the hand following what the eye had noticed and the mind had not yet finished processing. He could have set the printout aside and returned to it later, or passed it to a colleague with a note attached, or made a mark of some other kind. Instead, he did what felt natural in the moment, which was to draw the circle, and then, in the margin beside it, to write a single word. The word was "wow," followed by an exclamation mark, written in the same red pen, in ordinary handwriting, the kind of handwriting that belongs to a person doing paperwork rather than a person making history. There was no press conference attached to that moment, no announcement broadcast across the newswires, no gathering of colleagues to peer at the page together. There was a man sitting alone with a long roll of paper in a quiet room, and the feeling that something had happened that he did not have an immediate explanation for, and the word he wrote was the most honest expression available to him of what that feeling was. Surprise, certainly. Something adjacent to wonder. The particular quality of attention that arrives when the familiar suddenly produces the unfamiliar, when the columns of sameness briefly give way to something that does not belong to the category of sameness. The exclamation mark is worth a moment's notice on its own, because it is the kind of punctuation that appears when words feel insufficient, when the word itself needs a small gesture of emphasis to carry what it is being asked to carry. Wow. Standing alone is a complete response. The exclamation mark is the thing Ehman added, because even wow did not quite hold everything he was feeling in that moment, and so he gave it a slight push, the way a person might raise their voice not out of agitation, but out of the simple need to be heard across a wider space. That margin note became the name by which the signal would be known from that point forward, which is in its own way a fitting outcome. The signal had no sender attached, no return address, no accompanying message that explained what it was or where it had come from. It had only the shape it had left in the data, and it had the word that a single person wrote beside it in red ink on a paper printout in an unremarkable room in Ohio, several days after the moment had already passed. The naming of it was not an act of science, but an act of something more like instinct, the way language reaches for the nearest available handle when no precise term exists. For a long time afterward, the printout itself was simply an object in a filing system, the kind of document that organizations accumulate and store without quite knowing whether it will ever matter. It mattered. It became one of the more examined pieces of paper in the history of the search for signals from beyond the Earth, reproduced in books and articles, displayed in exhibitions, pointed to as an example of the strange and irreducible human dimension that runs through even the most systematic scientific work. A circle and a word in a margin, and the feeling behind them preserved on paper for decades. Ehman himself was careful in the years that followed when asked to describe what he had been thinking in that moment. He did not claim to have known immediately that the signal was something from another civilization, and he did not dismiss what he had seen. He described it as something that required explanation, as something that the data showed plainly, and that his understanding at the time could not immediately account for. That is a precise and honest way to describe the experience of encountering something genuinely unknown, and it is the same quality of honest suspension that the signal itself seemed to invite. Not a leap toward conclusion, but a pause, a circle drawn around the unfamiliar, and a word written in the space beside it that was the best available language for the feeling of not yet knowing what something is. The paper kept the record of that pause, and the pause kept its shape across the decades that followed. The decades that followed were not empty ones. Within weeks of the signal being identified and reported, astronomers were already pointing instruments back toward that region of sky, that particular arm of the constellation, Sagittarius, sitting low on the summer horizon as seen from the northern hemisphere, unremarkable in appearance, indistinguishable in any visual sense from the space immediately around it. The search began quietly and without ceremony, the way most sustained scientific work begins, which is to say with paperwork and scheduling, and the careful business of arranging time on instruments that were always in demand for other purposes. The Big Ear telescope itself returned to that patch of sky repeatedly in the months and years after the signal was found on the printout. It was, after all, already there, already scanning, already doing what it had always done. The same slow rotation of the Earth that had carried the signal through its field of view on the night of August the 15th would carry that same field of view through its range again and again across the following seasons, and the telescope recorded all of it faithfully, column after column of characters representing the faint background texture of the universe, and found nothing that resembled what had appeared that summer night. The signal did not return. The printout from 1977 remained singular. Other observatories joined the search over time. Telescopes in different countries, built on different principles, trained on the same coordinates, and listened at the same frequency, that quiet channel near the natural radio emission of hydrogen that theorists had long proposed as a kind of neutral, universal meeting point for any civilization capable of sending or receiving signals across interstellar distances. The reasoning behind the choice of that frequency was straightforward and elegant. Hydrogen is the most abundant element in the universe, and its radio signature is something any technologically capable civilization would almost certainly know how to detect, making it a natural place to begin a conversation or to listen for one. The astronomers who followed up on the signal knew this reasoning as well as anyone, and so they listened there patiently as the years accumulated. Through the 1980s and into the 1990s, the search continued in various forms, with instruments that were progressively more sensitive, better calibrated, more capable of distinguishing a genuine signal from the ordinary static of the cosmos. Each improvement in technology represented a new opportunity, a new chance that the signal might appear again and be recognized with greater clarity than had been possible the first time. The sky above Sagittarius was observed for hundreds of hours in total across those years, by multiple independent groups working on different continents, and the accumulated record of all that listening was consistent in a way that was neither comforting nor distressing, but simply true. There was nothing there that resembled the original. The Ohio State University program that operated the Big Ear telescope continued its broader search for radio signals from space until the telescope itself was decommissioned in 1997 and dismantled the following year in 1998 to make way for a golf course expansion, 20 years after the signal had passed through it. By that point, the patch of sky in Sagittarius had been examined so many times by so many instruments that the absence of a repeat had become its own kind of data point, its own quiet contribution to the record. The signal had arrived once and had not arrived again, and that fact was as carefully documented as the signal itself. Later search programs, operating into the 2000s and beyond, brought still more powerful tools to the question. Instruments with wider fields of view, faster recording systems, the ability to monitor multiple frequencies simultaneously rather than one narrow channel at a time. All of it was available and in use, and all of it was brought to bear on that same region of sky at various points across the following decades. The coordinates that Jerry Ehman had circled on a piece of paper in a university office were by this point well known within the community of people who study such things, a fixed address in the sky that required no further introduction, only further listening. And the listening continued to return nothing. It is worth holding that fact gently rather than heavily. The absence of a repeat signal is not evidence of failure in the usual sense, not a sign that the search was conducted poorly or that the instruments were inadequate. The search was real and thorough, and professionally sustained across an extraordinary span of time, carried forward by people who understood the difficulty of what they were doing, and continued anyway, not because success seemed imminent, but because the question itself was worth the patience. What they found was a consistent and accumulating silence, and that silence is its own kind of answer, even if it is not the kind of answer that resolves anything. There is a particular quality to a long, careful search that yields nothing. It is different from not having searched at all. The nothing that follows decades of attentive listening has a texture to it, a weight that a casual dismissal does not carry. Every hour of telescope time pointed at that patch of Sagittarius sky, every column of data reviewed and found ordinary, every instrument brought to bear and returned to its other work. All of it contributed to a picture of the universe that included, as one of its features, a single unexplained moment in the summer of 1977 that did not repeat. That moment remained in the record, intact and uncontradicted. The signal had happened. The data was real. And the sky above that particular region of Sagittarius continued to offer nothing further, year after year, with a patience that matched or exceeded the patience of the people studying it. By the time nearly half a century had passed since the night the signal arrived, the search had grown quieter in the way that very long searches sometimes do, not abandoned, but absorbed into a larger ongoing effort. The signal's coordinates one point among many that various programs continued to monitor as part of broader surveys of the sky. The specific urgency of the early follow-up had settled into something more like steady attention, the kind of watching that continues not in expectation of immediate discovery, but out of a kind of fidelity to the original question. Something had happened once. It was worth continuing to notice whether it happened again. It did not. Or at least, in all the years of listening that followed, nothing returned that matched the shape and character of what had passed through the big ear on that summer night. The silence held and went on holding, and became in its own way as remarkable as the signal that had prompted it. There were, of course, attempts to explain it. This is the natural movement of any scientific inquiry. The signal was unusual. It deserved examination, and examination means proposing mechanisms, testing them, seeing whether any of them fit the shape of what was observed. Several proposals were offered over the years, each one reasonable on its face, each one carrying a certain kind of explanatory appeal, and each one ultimately falling short of accounting for everything the signal had been. One of the more discussed proposals, which gained renewed attention several decades after the original event, involved comets. Two comets in particular were identified as having been in the general region of sky from which the signal appeared to come on that August night. The argument ran like this. Comets are surrounded by a diffuse cloud of hydrogen gas, shed as the comet's icy body warms in the sun and releases material into space. Hydrogen, spread wide around a moving body, could, in principle, emit radio energy at exactly the frequency at which the signal was recorded. The natural frequency at which hydrogen tends to radiate, the same quiet channel that had drawn theorists toward it as a logical place to listen for any transmission crossing interstellar space. If one of those comets had been drifting through the telescope's field of view at the right moment, it could perhaps have produced a brief, bright burst of radio emission at precisely that frequency, and then moved on, which would explain why no repeat was ever found. The comet was gone, and with it, the source. It was a tidy proposal, and it had the advantage of requiring nothing exotic. But the explanation carried difficulties that kept it from settling into consensus. The two comets in question were not confirmed to have been in exactly the right position with the geometry that the signal's behavior seemed to require. And more importantly, a hydrogen cloud diffuse enough to surround a comet tends to behave in ways that do not quite match the crisp, clean rise and fall that the signal exhibited. The way it built and then faded in a smooth, symmetrical shape, consistent with something fixed and distant, rotating into and then out of the telescope's line of attention as the Earth turned. A comet's cloud is spread out and moving, and the radio signature of such a cloud would generally be expected to look somewhat different from what was recorded on that printout. The comet proposal remained in circulation, plausible enough to discuss seriously, but not demonstrated. Another line of thinking focused on the possibility of a reflected signal, radio energy originating from somewhere on Earth, bouncing off some object in space, and arriving back at the telescope in altered form. Human technology had been filling the radio spectrum with signals for decades by 1977, and it was not impossible in principle that some emission from a satellite or from ground-based equipment could have been redirected toward the telescope by an unexpected surface. This kind of reflection does happen. It is a known phenomenon in radio astronomy, and it is the reason searches like the one conducted at Big Ear required such careful screening of known terrestrial sources. But the frequency at which the signal arrived caused this explanation significant trouble. The channel on which it was recorded was legally protected, set aside precisely to keep it free from interference, so that radio telescopes could work without contamination from human-made emissions. Broadcasting on that frequency from the ground would have been a serious violation of international communications agreements, and the monitoring systems of the time were specifically watching for exactly that kind of contamination. No source was ever identified. No satellite, no ground station, no aircraft or piece of equipment was found to account for what the telescope recorded. The reflected signal idea was examined and set aside, not disproven with absolute certainty, but unable to point to any actual source that would make the explanation work. There remained the possibility that the signal was simply a rare and unrepeatable natural event, some quirk of the cosmos, some brief alignment of conditions that produced a burst of radio energy at that particular frequency from some ordinary astrophysical process not yet fully understood. The universe is large, and it contains processes that produce radio waves across a wide range of frequencies, and not every such event has a tidy, catalogued cause. It was possible, at least in principle, that something natural and non-artificial had produced exactly the pattern observed. That coincidence had simply assembled itself into something that looked significant. This explanation had the advantage of requiring the fewest assumptions about unknown phenomena. But it, too, carried its own difficulties. The signal was not just at any frequency, it was at the specific frequency that theorists had identified, on purely logical grounds, as the most sensible channel for deliberate communication across interstellar distances. The intensity of the signal was also far above what background noise would account for. A natural coincidence producing all of those characteristics at once, in that particular combination, was not impossible to imagine, but neither was it easy to demonstrate, and no specific natural source was ever identified to make the case concrete. None of these explanations has been established as the true account of what happened. The signal does not fit comfortably into any of them, and none of them has been shown to actually produce what was recorded. In the formal sense, the signal remains unexplained, not in the sense that investigation has been abandoned, but in the clear and straightforward sense that no explanation has been confirmed, no mechanism has been demonstrated, no source has been identified. What passed through the Big Ear on the night of August 15, 1977, has not, after nearly half a century, been accounted for. This is not a comfortable place to rest. The mind tends to want resolution, a mechanism, a source, a story that closes. But science, in its more patient form, can hold an open question without forcing it shut, and the wow signal has remained one of those open questions, sitting in the record exactly as it was found, neither explained away nor confirmed as anything in particular. It is simply there in the data, the way a stone is simply there in a field, a fact without a settled context, a thing that happened and has not happened again. The various explanations offered over the years were not failures of intelligence or imagination. They were careful attempts to account for something genuinely difficult to account for, and they deserved the respect owed to serious inquiry. But they did not hold. Each one, examined closely, left some part of the signal's character unaddressed, and the accumulated effort of many careful people produced not a resolution, but a clearer picture of how fully the question remained open. And so the signal sits in that open space. Not alien, not natural, not artificial, not explained. Simply recorded, examined, argued over, and ultimately left as it was found. A single passage of radio energy, shaped in a particular way, at a particular frequency, lasting 72 seconds and never returning. The region of sky where the signal originated is not remarkable to look at, in any practical sense of that phrase. It sits within the constellation Sagittarius, which rises in the southern sky during summer in the northern hemisphere, a broad and busy region of stars when seen through any kind of magnifying instrument, but unremarkable in the way that most of the sky is unremarkable. Vast, quiet, offering no outward sign of what passed through it or what may lie behind it. There is no visible marker there, no star singled out as a source. The radio energy that moved through the receiver of the Big Ear telescope on the night of August 15, 1977, left no trace in the sky itself, nothing that even the most sensitive instruments have since been able to point to and say, that is where it came from. It came from somewhere in that direction, broadly, and that is the limit of what is known. The distance involved is, in the plainest terms, almost beyond useful imagining. Radio waves travel at the speed of light, and the patch of sky in Sagittarius where the signal's source is thought to have resided contains stars and open space at distances ranging from a few hundred light-years to many thousands, and possibly much farther. A signal that had traveled even a few hundred light-years would have left its origin point centuries before anyone on Earth existed who might have been equipped to receive it. A signal from farther still would have begun its journey in a time before the telescope, before the printing press, before the written word as most of the world came to use it. The 72 seconds that passed through the Big Ear were, in this sense, the end of a journey whose beginning recedes beyond any easy accounting. And yet the sky does not communicate any of that enormity. It simply sits there, as it always has, presenting the same unremarkable face to anyone who looks up on a clear summer night in the direction of Sagittarius. The stars in that region are not brighter or dimmer or differently arranged for what passed among them. The space between them is the same deep, empty quiet it has always been. If there was a source, it has not announced itself again. If there was a mechanism, it has not repeated. The sky absorbed the event, as it absorbs most things, without apparent consequence, without alteration, without any surface evidence that anything occurred at all. The astronomers who continued to search that region over the decades following 1977 were not, in practice, looking at anything visually different from the sky around it. They were pointing instruments at coordinates, specific numbers describing a position on the celestial sphere, the way an address describes a position on a map, and waiting for those instruments to register something at the relevant frequency, at the relevant intensity, with the relevant shape. They were, in a sense, waiting for the same thing the Big Ear had been doing all along, simply listening patiently while the Earth turned, and the coordinates returned nothing. The address held no repeat signal. The listening accumulated into silence. There is something in that silence worth sitting with for a moment, not because it is tragic or because it confirms any particular fear, but because silence of that duration and that consistency is itself a kind of information. Nearly 50 years of occasionally pointing instruments at a small region of the southern summer sky and hearing nothing is not the same as never having looked. It is an active, sustained, repeatedly renewed quiet, a quiet that has been tested and retested and has held each time. Whatever produced the signal of 1977, if it produced it, if it was a thing capable of producing rather than a coincidence of natural processes, it has not done so again within the range of what has been listening. There is no tidy way to hold this, and perhaps there is no reason to try. The signal exists in the record as what it is, a documented event, a column of characters on a paper printout, a red circle drawn by a man named Jerry Ehman on an afternoon sometime after the night it arrived, and a single word written in a margin. It has been examined and re-examined and discussed in scientific literature and in less formal places alike, and it has not changed. It does not yield more information than it contains, and it does not resolve. It simply persists, quiet and complete and untranslatable, the same 72 seconds it has always been. The printout exists in an archive somewhere. The telescope that received the signal was demolished in 2004, the land it stood on repurposed, the great flat reflector gone. But the coordinates in Sagittarius remain, fixed against the slow turning of the sky, accessible to any instrument pointed in that direction. The space there is cold and dark and traversed constantly by radio energy from countless natural sources. The background hiss of the cosmos, the particular frequencies given off by clouds of hydrogen drifting between the stars. And somewhere within it, or beyond it, or moving away from it, is whatever produced those 72 seconds. Or nothing is. The two possibilities rest side by side with equal composure. The night sky over Ohio is still dark in the places where it can be dark, away from the light that has accumulated around the cities and towns in the decades since 1977. On a clear August night, Sagittarius rises in the south, and the Milky Way thickens in that direction, a soft brightness made of distances too large to travel in any time that means anything to ordinary life. The signal came from somewhere in that soft brightness, or somewhere beyond it, and it has not come again. The sky holds that fact the way it holds most things, without expression, without preference, offering it to anyone who looks up and thinks to ask, and offering nothing further. It is enough, perhaps, to know that the listening has not stopped. There are instruments running tonight and tomorrow night, and on the quiet nights that follow those, their receivers open to the same frequencies, their records accumulating. If the signal returns, it will be noted. If it does not, the silence will continue to be its own kind of answer, or its own kind of question, or simply the condition of the search, patient, ongoing, and entirely untroubled by the fact that it has not yet found what it is looking for, because looking, in this case, is something that can be done indefinitely, and the sky is not going anywhere. The patch of Sagittarius sky, where it all began, sits above the horizon tonight, and will tomorrow night, ordinary and still, having offered one unrepeated moment across all the years of listening and keeping, for now, everything else to itself.